Good morning everyone. Myself Sanjeev Kumar. Today in this lecture we are going to discuss about 3-point start. Now, what is the main purpose of starters? Why you are not going to directly connect it to the supply for DC motors? Now, that's what the necessity of starter. So, the purpose of starter mainly to limit the starting current. So, the main purpose is limit the starting current. Now, why starting current is to be limited? Is there any excessive current is flowing through your motor? The main purpose of starter or else any other thing? Okay. So, the purpose of starter is to limit the starting current because initially heavy current drawn by the DC motor. Okay. So, why it is drawing excessive current? If you see the voltage equation of DC motor, simple DC motor voltage equation, V is equal to EB plus IAR. So where EB is the back EMF, nothing but generated voltage in the motors, and IARA is the drop, armature voltage drop. Now assume this motor, a DC motor, a simple DC shunt motor is connected to supply, but it is not running. It is at standstill condition. And at the very initial position when you are going to start the motor by closing DPST switch, so what will happen? Initially the motor is connected to supply, then it is starts running, but what is happening internally if you are not connected starter for DC motor? Okay, now initially you see the relations between back EMF, flux and speed. So the back EMF is also given by pi Zn P by 60 into T, and also EB is proportional to pi n, and whereas pi is proportional to EB by n. So you can see here flux and speed both are inversely proportional. Flux and speed both are inversely proportional. So we can say that flux increases, speed is going to be decreases. Now what happens here if initially your speed is 0? So what we can do is at standstill speed equal to 0. So what happens to your flux in the motor? It may increases to infinite value. So that may damage the motor. Now why this is happening? So initially your speed equal to 0, your flux tends to infinity. So what we are going to do to overcome this, and also the main effect is initially your back EMF is also 0. So why? Again this speed equal to 0. So when speed equal to 0, your back EMF is also 0 at standstill condition. Okay. Now when back EMF is 0, what is happening? If back EMF is 0, the voltage equation will become IARA. Why? EB is equal to 0. Now if EB is equal to 0, so the voltage equation is this, then what is armature current? Armature current is equal to V by RA. Now what happens if V by RA? So we know that armature resistance is very small. Okay. Now if armature resistance is very small and voltage in terms of hundreds, 220 volts, 230 volts. So what happens if you calculate, suppose IA is equal to 220 by 0.5. Let us assume 0.5 ohms initially. Now if you calculate the current, it may around you may get 440 amperes. So which is very high current. So whereas the rated current is only 20 amperes. Now almost 20 times of the current drawn by your motor, so which will damage the armature windings. So initially the current drawn by your motor will be very high due to back EMF is 0. Why back EMF is 0? Speed of the motor is 0. Why speed of the motor is 0? Initially flux is going to be infinite value if your speed is equal to 0. Okay. So to overcome this, to overcome all this, what we are doing, we are going to insert a extra resistance at starting of the motor. So while it is going to run, it is going to pick up its speed from 10%, 20% to 100% of its rated speed. Now we are connecting some resistance. Now you can see here same equation I am going to consider here. So V is equal to IA RA. Now if RA is small, so IA is going to be very high. Suppose I connected some resistance RA plus RX. Now what is RX? RX is the resistance to be connected in series while it is going to be started. So what is meant by RX? RX is the starting resistance. Rx is nothing but starting resistance, which is to be inserted in series with the armature resistance. It is in series with armature resistance. So if you calculate the current, now you will get, you can see here, so IA is equal to V by RA plus RX. Now RX value may be 100, 200, so that it can keep your armature winding in a safe value, so that your starting current is going to be limited. Your starting current is going to be limited and it will be in safe condition. It will be a good condition for your armature winding. So that's why we have to connect a starting resistance, and once it picks up the speed, you can remove that extra resistance by making some mechanism. So that's why the main purpose of starter is to limit the starting current, and once it pick up its speed, so you can disconnect that, you can bypass that resistance and you can run the motor in a similar manner so that it can bear the load. Okay, so this is about what is the necessity of resistance. Initially back EMF is 0, so that your armature current is going to be higher value. That's why I am connecting some extra resistance in series with the armature. Now we will going to 3-point starter. Okay. So it is the 3-point starter. We can see here we are having a 3 terminals L, F, A. Okay, so it is nothing but L stands for line, F stands for field, and A stands for armature. Okay, this plus minus, this is DC supply. Okay. Now you can see here it is connected to 3 terminals. That means line, whatever the your line supply is going to motor is connected to this terminal, and field is connected here, and armature is connected here. You can see here this is armature winding, field is indicated by FF, AA, armature, and one line terminal is connected, so that you can see the important parts of 3-point starter. So why it is called as 3-point starter? We are having the 3 terminals in 3-point starter to connect your motor. That's why it is called as a 3-point starter. And you can see the main parts of the construction of 3-point starter. You can see here OLR. So what is meant by OLR? So OLR stands for overload release coil. Okay, and also you can see here one more NVC is there. NVC is there. So no volt coil. And also you can see here DC supply, fuses are there. So 125% of the rated current, the fuse rating, and DPST switch is there, and a triangular iron piece that means act as a plunger for this, so that it can release the over when it is going to be disconnected to the either short circuit the novel coil, and a handle is connected to the spring so that you can move the handle from off position to run position. And also you can see here resistance is connected, so you can move the handle step by step, so that extra resistance is going to be decreased. Okay, next. So run terminal is there, that is the final terminal. Spring is there, so spring can what we can call it as, it can handle, it can bring back the handle to original position once your NVC is going to be demagnetized. And this is the connection for field. Now you can see here the 3-point starter mainly limits the starting current. Now you can see here the connections. The NVC is connected in series with field. Okay, so NVC is connected in series with field winding, and the starting resistance is connected in series with armature. So this current in armature, that means load current is flowing through this one, so it is also connected in series with your overload release, so that overload release bears the line current, whereas your NVC bears the field current. You can see here field current is very small, but line current is very high. Okay, so this is about the 3-point starter connection and main ports. Now we will see how your 3-point starter is going to be works. Okay. Now we are going to close the switch, DPST switch, and the supply is flowing through the line to overload release coil and reaches to the handle. Now what I am doing, I am going to change the handle step by step. So that first step, so you can see here this is the total resistance. If you keep at the first point, the resistance should be maximum. Okay. Now I am keeping the first point, so the resistance is maximum, and from this position you can see what is the directions of current. So the current is coming here from this coil, so this coil is not engaged. This coil is only engaged when it is a higher current, more than rated current will flow, so it is not engaged, it is directly enters into the handle, and from here you can see it is having a 2 paths. So one path is going upper line and another path is going into armature. Okay, you can see here once this handle is moved onto place 1, the current is divided into 2 portions. So this is first and this is second. So this is 1 and this is 1 dash. Now 1 is going into the NVC and this current is going into the armature directly. Okay. Now again I am moving into the 2, again same, the current is entering into the novel coil and again some current is entering into the armature. Again if you move to the third position, some current is again entering into the NVC and again some current is entering into the armature. But what is happening as you are moving the resistance from first position to second, third, fourth, fifth, so the resistance is going to be decreases. Now what happens if the resistance decreases? You can see here, so at first position this current is going into the NVC. So you can see here NVC is connected to field. So when the field is excited, so it creates a magnetic field which cuts the armature conductors. Now you can see here initially whatever the current flowing through this NVC is directly flowing into your field winding. So slowly this field flux is going to be set up and your armature is also starts very slowly. Now once it moves to the second position, so this current entering into the NVC somewhat increases, so it will strengthen the magnetic field. Now which cuts the armature conductors, so armature starts rotating. And again number 3, so similar manner So this process is continuous. The field flux setups, armature cuts, EMF will this. That means back EMF. Again, this field winding is going to cut, strengthen, and again cuts this, so that the armature speed is going to be increases. Now this process up to 6, it is going to be same. Why? There is a extra resistance is going to be until run position. Now once you close the switch at a run position, so the total extra resistance is going to be disappeared. So total extra resistance is going to be bypassed. Why? You can see this terminal. So if this handle is moved here, so what is happening? This extra resistance R1, R2, R3, R5, R5, 6 is going to be totally, it is going to be bypassed. So it is connected to the your armature. That means maximum current is flowing to the armature, but you can see here that this terminal is connected to NVC. Now whatever the current coming here, it is entering, this current is again flowing into the field winding, but it is having a smaller value. So your field winding is excited, and also armature winding is cut by the magnetic flux, field flux, so it starts rotating. So like this, your 3-point starter is going to be run. Now what is the purpose of NVC and what is the purpose of OLR here? Now as earlier said, so this handle is moving up to 0.6 and run position, so it may not remains at that position only. Why? We are moving it manually. So it is moving like this, 1, 2, 3, 4, 5, 6, 7. If you remove your hand, it is again come back to first position, and it makes a sparking also. So that you have to fix your handle. Somebody has to hold this handle so that it can be remains at this run position until your motor is going to be run. So the remedy for this is to NVC. We are using a no volt coil here. So as your handle is moving up to here, so when it is comes to run position, so this no volt coil attracts the soft iron piece, as written here. This soft iron piece is attracted here, and it will fixed with this, that means engaged with this NVC. So it is held by this no volt coil. Okay. So this no volt coil main function is to hold the handle until power supply is going to be interrupted. So what is the main purpose of no volt coil? No volt coil holds the handle, holds the starter handle until power supply is going to be interrupted. So once the power supply interrupted, so this handle demagnetizes and it comes back to the off position. So that this no volt coil will holds the starter handle until power supply is there. So once the power supply is interrupted, this coil releases handle, so it comes back to off position. So supply is going to be cut off for your motor. So no supply to armature and field, so it remains in standstill condition. So the main purpose of no volt coil is to hold the starter handle until power supply is going to be interrupted. Okay, so in written as, so NVC holds the starter handle. Okay. Suppose if NVC is not connected in this 3-point starter, what will happen? If this NVC is not connected, so this handle may not remains here and it is again come back to the off position. So if there is a NVC, it will magnetizes it and it will attracts this handle and it will holds until the power supply is going to be interrupted. Now you can see the connection diagram for NVC. So the terminal from your starting resistance is coming into node coil, and from this it is directly connected to the field winding. So NVC is connected in series with field winding. In series with field winding, we know that field current is very small, so small current is enough to magnetize this, and it will holds the starter handle. There is no large current is required like armature, it will only small current is required to hold it. So until the field current is flowing, so it will hold this, and it is also connected to the triangular piece, iron piece, which is placed near overload release coil. So this also serves when overload coil is working. So if the motor draws extra current, again NVC is going to demagnetize, so that the power supply is going to cut off. So NVC also works when there is a OLR is going to work. So that's why NVC is a very important device in your 3-point starter, which holds the starter handle and also serve when there is a overload coil is going to work out. So it will trips similar to your when the power supply is going to be off. Now we will go coming back to the OLR. So what is OLR? OLR is nothing but overload release. So overload release coil it is. Now overload release coil, you can see here, it is directly connected in series with the supply. It is directly connected in series with the supply and also in series with supply. So whatever the current coming from your supply directly bear by 3-point this overload release coil. So you can see the connection, the current is directly entering into overload release and moving to handle. From the handle it is going into NVC and also from armature. So you can also say that it is connected in series with the armature winding. So the overload release coil carries line current. It carries line current. We already discussed that. The NVC carries only field current, very small, but overload release coil bears large current which is equal to line current. So this overload release coil itself, the name itself indicates overload. When it carries a excessive current that is greater than rated current, nearly 1.25 times of its rated current, then the overload release coil is going to be magnetizes, and which attracts this lower triangular iron piece, and this is connected to the NVC. So you can see here this NVC, two connections are given for this triangular piece. So when this overload release coil magnetizes, it will attract this triangular iron. So this is more upward direction. So when it closes these two contacts, then your NVC is going to be short circuited. So once NVC is going to be short circuited, this coil is going to be demagnetized, and once it is demagnetized, this handle is going to be not holded by NVC. So this handle is coming back to the off position. So once this handle coming back to the off position, supply is going to be cut off for your 3-point starter. Okay, so the overload release coil mainly works when there is a excessive current carried by motor. Let us say motor is going to be armature current, line current. Okay, so overload release coil mainly functions when there is a excessive current. That means almost, if you see the rating, 1.25 times of the rated current. You can say 1.25 times. For the fuse rating we are going to fix for 125% of the rated current. So nearly 1.25 times of the current. If you are line carrying, then this overload release coil is going to be works out. So at that current, your fuse is also going to melt out. So overload release coil also, the manufacturer will get certain value so that it is going to be tripped. That means it is going to attract this lower iron piece, triangular iron piece. So it will short circuit the NVC so that supply is going to be cut off. What do we call this? NVC short circuits. So NVC is going to be short circuited. So this coil is going to be very important when it carries a excessive current, and also this no volt coil mainly serves for when there is a sudden power supply is going to be cut off. This will releases. Okay, if sudden power supply is cut off, what will happen? If sudden power supply is going to be cut off, your motor, suppose this field winding gets opened, so flux increases to higher values, so flux increases to lower value, speed becomes very dangerous. So that's why you have to protect the motor, so it should have some flux in the field winding. So that's why this no volt coil mainly take care of the motor protection, and overload release coil also when there is a excess current is carried by the armature line currents. Now we will discuss about what is the difference, comparison between 3-point and a 4-point starter. So 3-point starter having 3 terminals, whereas 4-point starter having 4 terminals. So what is the advantage of extra terminal? You are providing one extra terminal. What is the advantage of it? Okay, so this side 3-point starter and this side is 4-point starter. So the first point is it is having 3 terminals and it is having 4 terminals. So what are the 3 terminals? Line, armature and field. Whereas in 4-point starter, line, armature, no volt connection and field. So N stands for no volt connection, no volt coil connection. So LANF, whereas LAF is the 3 terminals. Next, the second one is NVC in series with the field winding. In 3-point starter, NVC, no volt coil, is always in series with the field winding, whereas in 4-point starter, the NVC is separately connected, nothing but both NVC and field winding are connected in parallel. So it is not connected in series with field winding. In fact, it is connected in parallel. Okay. Next, third one is speed control affects the current through the NVC. So you can see the second point, NVC and field winding both are connected in series. So if you change the current flowing through NVC, field current also changes. Now if field current changes, flux changes. If flux changes, speed will be changes. We know that what is the flux and speed relation. So flux is proportional to EB by N. Now if you decrease the flux, speed will increases. So that if your EB is going to constant, so flux decreases, immediately speed of the motor is going to increases. So this is the main effect in 3-point starter. Now speed control does not affect the no volt coil. So speed control does not affect the no volt coil. So here both are in parallel, so there is no effect on field current, so that field current is independent of no volts, whether it is small value or higher value, no volt coil, so it may not affect the field winding. Next, it provides the protection against overload and short circuit. So 3-point starter provides OLC used to protect the overload, and no volt coil that makes a short circuit of NVC. So when there is a short circuit, immediately your no volt coil releases the handle, so it is going to be protected. And also overload, so higher currents, excessive currents flowing through that, it is also going to make a protection against, so it releases the no volt coil. Next, in 4-point starter, it provides the protection against overload and short circuit fault. So same, the protection for both 3-point and 4-point starters is same. In fact, it is having some extra protective resistance, so that this 4-point starter also provides overload and a short circuit fault protection. Next, in 3-point starter, not suitable for variable speed motor. So since the flux you have to remain constant, your current flowing through NVC is going to be constant to hold the starter handle, so the flux is also constant. If flux is constant, so immediately speed is also constant, so N is also constant. So that's why this is used for constant speed motors. Next, in 5th point, it is used for variable speed. Now you can change the field current so that you can change the speed, so it may not affect your field winding, so that this is independent of your no volt coil. You can go for a different speed, so that's why it is used for variable speeds, that is 4-point starter. Next, in 3-point starter, the last one is, it is used for shunt motor. Just now we said it is used for constant speed, so that the characteristics of shunt motor will give constant speed, so that's why it is used in shunt motors. So if you see the applications, lathe, constant speed, so they are running spinning wheels, so that they are used for DC shunt motors. Now if you see the 4-point starter, they are usable for the shunt as well as compound motors. Both it can be used, so it will gives the both performance. If you see the pressing mills, intermittent loads, so it can use it for the both shunt and compound. So if you see the pressing mill, so load is there and certain duration is there, so time interval, and now again it is going to press, so it is used for intermittent loads, that is shunt and compound pressing mills. Okay, so that's why 3-point and 4-point starters are similar in nature except one terminal and some other differences in terms of speed and applications. So 3-point starter is used for shunt, whereas 4-point starter is used for compound motors.